All right, here's an example with linear programming. Yum's Bakery bakes 2 types of breads, bread A and bread B. One batch of bread A uses 5 pounds of oats and 3 pounds of flour. One batch of bread B uses 2 pounds of oats and 3 pounds of flour. The company has 180 pounds of oats and 135 pounds of flour available. So we're going to go ahead and stop there and set up a table. So we want to identify our variables. So we have X and Y. So we're going to let X be the number of batches of bread A. And then we'll let Y be the number of batches of bread B. Now bread, they're saying, is made up of 2 things: oats and flour. And there are some restrictions that we need to write. So I'm going to create the table. I'm going to let the first column be the constraints for the oats and the flour. The second column is just going to be about bread A with its restrictions. The third column is going to be the restrictions for bread B, and then the max amount allowed. So let's go up to the given information. So in bread A, it uses 5 pounds of oats and 3 pounds of flour. Bread B uses 2 pounds of oats and 3 pounds of flour. And then we have some maximum amounts. The company has 180 pounds max of oats and 135 pounds max of flour. Step 2 says, write the objective function for the profit. So Yum Bakery wants to make the maximum profit. So A yields $40 and B yields $30 for every batch it makes. So profit equals $40 for every batch of bread A plus $30 for every batch of bread B. Now we need to write our constraints. So we cannot have a negative amount of bread A batches or bread B batches. So the X and the Y always have to be a positive number. Now we need to do a constraint on the oats. So we say 5x plus 2y has to be less than or equal to 180. So that's the restriction on the oats. Then we have the restriction on the flour. 3x plus 3y less than or equal to 135, and that's on the flour. now we graph the system. So the black pieces right there are going to create it into that first quadrant. And then we have to graph the red and the purple. So we have 5x plus 2y less than or equal to 180. So this time I'm going to go ahead and find the intercepts where it crosses the x-axis and the y-axis. So the x-axis represented the number of bread A, and the y-axis represented the number of bread B. So I'm going to go ahead and find the x-intercepts. First for this red one. So I'm going to substitute 0 in for y. And then solve for x. So x equals 36. So the x-intercept is 36, 0. The y-intercept, we're going to let x equal 0. So we get 2y equals 180. Divide both sides by 2, and we get 90. So the y-intercept is 0, 90. We have to do the same thing with the purple one. We have to find the x and y-intercepts or convert it to slope-intercept form. So we have 3x plus 3y less than or equal to 135. So we need to find the intercepts. So x-intercept, we let y equal 0. We solve for x. 135 divided by 3 is 45. So we get 45, 0. Notice that the y-intercept is going to produce the same value of 45. So 0, 45. All right. Those are the ordered pairs to help us to graph our lines. So I'm going to make every one of these 10 units. So this would be 20, 40, 60, 80, 100. And then same thing in the vertical axes, 60, 80, 100. Now let's go ahead and graph the ordered pairs. So I'm going to start with the red one. So I'm going to go over 36 up 0, and then over 0 up 90, creating our vertical line. And remember that is y is less than. So we would shade less. The purple one, y-intercept and x-intercept of 45, 0 and 0, 45. Then we shade below. And the region that overlaps is right in there. Then we need to find the vertices. So this first vertice is 0, 40. Sorry, oops, 40, 0. Then these two lines intersect at 30, 15. Then we have this one up here, 0, 45. And then down here at 0, 0. So those are your 4 ordered pairs for your feasible region. Step 6 now says evaluate the objective function at the vertices. So our objective function is this blue equation in step 2. It's your profit. Now we go ahead and substitute in the 4 vertices. So 0, 0, we don't make anything. 0, 45. The profit is $13.50. 30, 15. The profit is $16.50. And the profit is $1,800. So if we look at those 4 profits, the last vertice that we inputted, this is our X, and our Y made a profit of $1,800. That's our maximum. So what does that mean? The bakery should make 45 batches of bread A. Sorry, A was the X variable, and 0 batches of bread B for a max profit of $1,800.